My name is Meredith Nettles. I'm a professor at Columbia University in earth science. I got into this field essentially by accident. I had always been interested in science and in earth science a little bit, plate tectonics, but when I went to college, I thought I would study something that could let me act in public service later on, and I studied government when I was in college. But I ended up being able to do an internship or a research assistantship in seismology, which is the study of earthquakes and the interior of the earth. And I really loved it. And so I actually switched over eventually into earth science. I took some time off after college, took some more classes, and then went to graduate school in earth science. So it was a bit happenstance finding something that I really liked, and here I am. Right now, I have a really great project that I'm working on in Greenland. We call it the Greenland Lakes Project, and it's related to understanding how lakes that form on the surface of the Greenland ice sheet when the melt season occurs every summer, what happens to that water during the melt season and how that affects the behavior of the Greenland ice sheet. Water ponds on top of the ice sheet, and then sometimes it drains over the surface, and sometimes that water actually opens up a fracture in the bottom of the lake and drains for a kilometer down to the bed of the ice where it meets rock, and that can really change the way that the ice flows. We're expecting more melt at higher elevations on the ice sheet, so we're really working on understanding how those changes will affect the hydrology of the ice sheet and the behavior of the ice. It's a project that we're doing as a team. I'm the so-called lead principal investigator for the project. So in addition to working on the science, it's like running a small business, managing a team of people and a budget, and making sure all the right pieces are in the right places at the right time, estimating how we're going to get some helicopter fuel where we need it at the same time that we're thinking about the physics of the ice sheet. So it's a role that I enjoy because it involves a lot of different kinds of challenges, the opportunity to work with a variety of people, and to really think through in a physical and mathematical way the way that the ice is changing and the implications that that has for us in society. The fieldwork has constant challenges. Things are always changing. It's a situation where you have to make a plan or nothing will happen, but you have to be prepared for the fact that the plan will always change. So whether that's a case of planning for how much time we need to spend on the ice, but then the weather being much worse than expected and constantly revising that plan, or simply in recent times, we're working on this particular project through the COVID era. So we've had a full year's delay in the project as a result of COVID restrictions. So there's always something that's changing. And I think that's the biggest challenge, is just being flexible enough to adapt constantly to all those things that happen. There are specific challenges like cold weather, the extreme environment, being prepared for all of the hazards that we might face, along with trying to obtain data in the most advantageous place scientifically. Putting all those pieces together is a constant but very rewarding challenge. The most rewarding thing about working as a scientist for me is being able to learn something new that no one has figured out before. And that's something we're really able to do in this type of research, learn new things about the earth and the way it works, and finding something, a new insight and a new piece of the puzzle that moves us forward in our understanding of the way the earth works is by far the most rewarding part of the job.